In this video, we're going to look at some quadratic models, meaning we're going to be looking at applications based on quadratic functions. So look at the top of your notes. It says applications with quadratic equations. The first one that we're going to talk about is a very common one, a very important one, called maximizing revenue. And it says in economics, the law of demand states that P, which represents the unit selling price of an item, and X, the number of units sold, are related. And that is kind of common sense. As one increases, the other decreases. So as the price goes up, the demand goes down. As the price goes down, the demand goes up. It makes sense. The equation that relates P and X is called the demand equation. And we're going to be looking at that demand equation in this example. It says the marketing department of Texas Instruments has found that when certain calculators are sold at a price of P dollars per unit, so P represents the price, the number of calculators sold, which is X, is given by this demand equation. The number sold is equal to 21,000 minus 150 times the price. So what we want to do is express the revenue R as a function of the price. Well, the first thing that means is we want R based on P. That's what it means when it says as a function of. And what we know is that the revenue that you bring in will be the number sold times the price that you have sold them for, where we know that X, I'm going to write this down, where X is equal to 21,000 minus 150p, and we know that from up here. Now when it says express the revenue as a function of P, it means the only letter that is supposed to be in our equation is a P, not an X. So what we're going to do is replace that X with what it is equal to. So R of P is equal to, I'm going to write this P first, times X, but X is 21,000 minus 150p. Continuing with that, let's simplify a little bit. So R of P is equal to, if I distribute that, I'm going to get negative 150p squared plus 21,000p. That is revenue expressed as a function of P, meaning only P's are in the equation. Now notice what I did. When I distributed, I'm going to show you this little step here. I would have had 21,000p and then minus 150p squared, but I wrote it in the correct order where the p squared comes first. So what we know about this, what we know about this equation by looking at it is that the A is equal to negative 150, the B is equal to 21,000, and C is equal to 0 in that quadratic equation. So what does that tell us? It tells us, since this is a negative A, that the parabola, which is the graph of the quadratic, opens down, and that this is a max point. All right, next it says what unit price should be used to maximize the revenue. Well, what we really want to know is to maximize the revenue means what is that max point? Well, that max point is the same thing as the vertex of the parabola. So what we want to do is find the max point. And in this case, the max is going to be the point negative b over 2a, and then f of negative b over 2a. So we can do that. So let's find the negative b over 2a first, because that's the vertex point. So negative b, going back to those values right there, negative b would be negative 21,000 over 2 times negative 150, which is 21,000 over 300. I can divide quickly by 100, and when I divide 3 into 210, I end up with 70. Now what did I just find? I just found this part of the max point. So I know my point is going to be 70, and then this part right here, the y part, is going to be f of 70. So to find f of 70, I plug that into my revenue equation, and I get negative 150 times 70 squared plus 21,000 times 70. And that's just a calculator problem. And when you put that into your calculator, you get 735,000. So 735,000 is the second part of that point, the vertex point or the max point. So part C says, if this price is charged $70, what is the maximum revenue? Well, we just found it, $735,000. So that is where, on our parabola, the price is best. It's the best price you can charge for those calculators. If you charge less, your revenue is going to go down. If you charge more, your revenue is going to go down. But right there at that point, that's where you are maximizing the revenue. So I want to make sure you see the relationship between this number, the price of the calculator, and this number, the amount of revenue that you have at that max point. D says, how many units are sold at this price? Well, what letter represents what variable? The units sold. That would be X. Don't we have a formula for X? Going clear back up here to the top. X is equal to 21,000 minus 150 times whatever we said was the maximum price that will get us the best revenue, which is 70. Again, a calculator problem. And you get 10,500. That's how many calculators, I'm going to write that, will be sold if you charge $70 and maximize your revenue. Now it says graph R. So in order to graph R, let's look at getting this first set up. And I show the window here for your calculator. I'll bring my calculator over in a minute and make sure you know where to put that. But what we're going to have down here is the price in dollars of our calculator. And I know this is going to seem odd to you, but trust me, I figured out the window. Well, that's another lesson. We're going to count by 14. So it's 14, 28, 42, 56, 70. Then we're going to continue 84, 98, 110, 126, and 140. On this side, I'm just going to write R for revenue. And here, it's going to be in the thousands. So I'm not going to write all those zeros. So when I write this is 100, I mean 100,000. So actually, we should put in our label of our axis, we should show that that is in thousands. So we're counting here by 100, and up here we have 800. We'll fill that in later, okay? So now, how do we know where to start? Well, if I charge nothing for my calculator, I'm not going to make anything, right? So I know that this point is on here. So we want to find the X-intercepts. With the X-intercepts are when R, the revenue, is 0. So that would be here and wherever else it's going to be. So we would take our equation, negative 150 p squared plus 21,000 p, and set it equal to 0. I can factor out a negative 150 p, and I'm left with p minus 140 equals 0. So either negative 150 p equals 0 or p minus 140 equals 0. Here I divide by negative 150 and I get p equals 0. Well, that makes sense. If the price is 0, then obviously I have no revenue. But there's also going to be a price where it's so high that nobody buys them. And that's going to be this one. So I add a 140 and I get p equals 140. This is also a 0. Now I already have another point on here. That is this point. So that point is the point 70, 735,000. So this is 700 right here. So it's a little bit above the 700. So I'm going to kind of go up and it's about right there. That's my max point. And I know that it opens downward, and I know that it's a parabola. So the shape of that parabola is going to be roughly like this, and mine is not going to be symmetric, but it should be. It should look something like that. Now, you can actually do this in your graphing calculator. So let's take a look. I'm going to bring the graphing calculator over, and we're going to use the window that I show right here, and we'll graph, and you'll see you're going to get something that looks like this. So turning it on, I have absolutely no clue what is in here. I want to go to my window, and let's set that up first. So I want to go from x min of 0 to x max of 140. We're going to count by 14s instead of by 1s. My y min here, you can see is going to be 0, and I'm going to go up to 800,000. And we're counting by 100,000. 100,000. Okay, now I've got to put my equation in. I've got some other equations in here, so let's get rid of those. And my equation, I'm going to move this for just a second, is that equation that we got right up here. So remember, this is our y. These are going to be our x's. So when I go in and I put in my equation, it's going to be negative 150x squared. Now get out of exponent land. Plus 21,000x. We hit graph, and you're going to see a graph that looks very similar to our sketch, except this one is actually perfect and it is symmetric. But you can see, I'm going to try to point this out. Up here is that max point, and that max point is the point that we found, 70,735,000. All right, let me move the calculator, and let's look at a different kind of maximizing. This one was maximizing revenue. So on the next page, we're going to be looking at maximizing area. This is a little more straightforward. Maybe, I don't know, it kind of depends on how you think. But let's look at the example. It says a farmer has 2,000 yards of fence to enclose a rectangular field. What are the dimensions of the rectangle that encloses the most area? So he wants to get that fence around the perimeter of the rectangular field in a way that he has the most area inside. So I'm first going to draw a little sketch of a rectangle. I don't really know what it's going to look like. It might be more square. It might be longer and skinnier. I don't know. We're going to call this width, and we're going to call this length. And now let's write down a few things that we know. Since we're talking about perimeter, and how do I know that? Because it says he's got 2,000 yards of fence to enclose the field. So this is related to perimeter. I know from a rectangle, I'm going to write this up here, that P equals 2L plus 2W. That is true for rectangles. And I also know from this problem that P is 2,000. So I know that 2,000 equals 2L plus 2W. So what I want to do is I want to solve, I don't want to have two variables here, I just want to have one. I want to solve this one for length, and I can do that by subtracting a 2W from both sides. That gives me 2L equals 2,000 minus 2W. And now I'm going to divide everything by 2, and I get L equals 1,000 minus W. So I can go over here and say L is 1,000 minus W. So we're going to use that. I also know about a rectangle that area is length times width. Isn't that true? So I know that area is 1,000 minus W, that's my L substitution, times W. Or area, I'm going to distribute that, is 1,000 W minus W squared, and I'm going to turn it around, or area as a function of width is equal to, meaning that's I only have w's in it, negative w squared plus 1,000 w. So that's the first thing that I know. Now, from there, I can write my A, my B, and my C. My A is negative 1, my B is 1,000, and my C is 0. And now the question is, when is this area maximized? Well, it's maximized, just like the last one, at the vertex of a parabola that opens down. How do I know it opens down? Because the A is negative. It's a negative 1. So what I really want is to find the vertex. That's going to equal my max point where my area will be maximized. So let's first find negative b over 2a. So that's going to be negative 1,000 over 2 times negative 1, or if you figure that out, it's just 500. So what that means is my area will be maximized when now what does this represent? Well, we were doing area as a function of w, so this represents w. So when my width is 500, my area will be maximized. What will my area be? I have to find A of 500. So A of 500 is equal to negative 500 squared plus 1,000 times 500, just a calculator problem. The area, the maximum area when the width is 500, if you work that out on the calculator, is 250,000. Now, what does that mean? It means when my width is 500 yards, my area is maximized at 250,000 square yards. So the second part of that vertex is 250,000. So that is when the area is maximized. Now, if the width is 500, what is the length? Well, we know that the length is 1,000 minus the width. So it is also going to be 500. In other words, the area is maximized with a square rectangle. Width 500, length 500. And that's always going to be true. A square rectangle has more area than any other kind of rectangle. All right, let's look at another one. Same idea, a little bit different. David has 400 yards of fencing and wishes to enclose a rectangular area. First, express the area of the rectangle as a function of x, where x is the length of the rectangle. So once again, we're going to draw our sketch. This time, instead of using x, I think let's change this and let's actually use L, where L is the length of the rectangle. So rather than finding A of W, we're going to find A of L here. So we have our width and our length. So I'm going to start out the same way. I know that, let's do it over here. Perimeter is 2 L's plus 2 W's. Okay, last time we solved so that everything was in terms of, if you look back up here, all I had was W's there. I'm going to do it this time, so all I have are lengths. So I'm going to solve for W. So that means I'm going to subtract a 2L. That gives me P minus 2L equals 2W. But I know that the P, the perimeter here, is 400. So 400 minus 2L equals 2W. I divide by 2, and I get W equals 200 minus L. So this is 200 minus L, kind of little there. So I know that W is 200 minus L, and I know that area is length times width. So area as a function of length is equal to the length times the width that we just found, 200 minus L. Or A of L is equal to 200L minus L squared. You can see this is just like the last one. We're going to turn it around. A of L is equal to negative L squared plus 200L. Let's label our A, B, and C because we're talking about maximizing, so that tells me a vertex. A equals -1, B equals 200, and C equals 0. So I know that it's opening down. I know the area is maximized right there. That's my max point, but it's also my vertex. So I need -b over 2a, which is -200 over 2 times -1, which is just 100. So I know that when my length is 100, my area is going to be maximized. So when my length is 100, what is my area? Put it right back into that formula. A of 100 is equal to -100 squared plus 200 times 100. I ran off the screen here. There we go. Put that in the calculator. A of 100 equals 10,000. So when my length, this represents my length, is 100, this represents my area. My area will be 10,000 square, what were these, yards. That is my max point, my vertex point. Now, what are my dimensions? Well, I know that length is 100, and I know that width is 200 minus length, so 200 minus 100, or it is also 100. And once again, you can see for C, the maximum area is 10,000 square yards, and it is, let me pull this up so you can see it. It is when the rectangle is square. Now, sometimes you can't get a square rectangle and whole numbers, but in these two examples, both of those you could.